Hey guys, and today I'm going to show you how easy it is to find the derivative of ln x using the definition of a derivative. So what is the definition of the derivative? The derivative of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x and all that divided by h. Okay, so if you apply this to ln x, we can say it's the limit as h approaches 0 of ln of x plus h minus ln of x all divided by h. Okay, so the first thing that you'll notice is that there's a very clear logarithmic property sticking out here. When we have the difference of two logarithms, so ln a minus ln b is equal to ln of a divided by b. So we can now combine these two to get this is now equal to the limit as h approaches 0 of the ln of x plus h divided by x over h. Alright, and now the h can come out as the limit as h approaches 0 of 1 over h times the ln of x plus h over x. Alright, and now we can use another logarithmic property that says a times ln of b is equal to the ln of b to the a. So we can now say this is the limit as h approaches 0 of ln, and now actually the inside ln we can actually change a bit to make it a little easier to work with. We can essentially distribute this over the denominator and say that this is x over x, or 1, the ln of 1 plus h over x. And then this is all inside the ln actually, because the power is going to be pulled up to here, raised to the 1 over h power. Okay, so let's see where we can go from here. So I'm going to make an important substitution actually, saying u is equal to x over h. And it will become very clear why I use the substitution in a moment. So the first thing we do when we make a substitution into a limit is see how does this change as we replace it with u. So what happens as h approaches 0 to x over h? So in general, as h approaches 0, x over h will approach infinity. So we'll say that as h approaches 0, u, or x over h, approaches infinity. So now this is actually the limit as u approaches infinity of the ln of 1 plus, and then what is h over x? This implies that 1 over u is equal to h over x, because we flip both sides. So now 1 plus 1 over u, and now what is 1 over h? So let's see how we can do this. So we know that because of this implies that h is equal to x over u, with x over u, and that implies that 1 over h is equal to u over x. So we can then make that substitution and say that this is then ln of 1 plus 1 over u to the exponent u over x, that limit as u approaches infinity. Now this is starting to look very similar to the definition of e, one of the definitions, which says that e is equal to the limit as n approaches infinity of 1 plus 1 over n to the exponent n. So we nearly have that. We have this x in the denominator. So what if we could use the power of a power property in reverse, which says that, a to the xy is equal to a to the x to the y. So this is actually the limit as u approaches infinity of the ln of 1 plus 1 over u to the exponent, u times 1 over x. That's the same thing we did earlier, and we can now say this is the limit as u approaches infinity of ln of 1 plus 1 over u to the u, and then all that to the 1 over x. The 1 over x is inside the logarithm, just so you know. Now let's see what we can do. So now as u approaches infinity, the inside will approach e. So this is actually e now. Now that we've used this to become e, the limit goes away because there are no other u terms. So this is actually just the ln of e to the 1 over x. And then we pull the 1 over x down, and we get 1 over x ln e. What's ln e? 1. So this is 1 over x. Therefore, the derivative of ln x is 1 over x.